Okay, so again here we'll be doing what's called logarithmic differentiation. Rhythmic differentiation. We don't necessarily have to do that here. Okay, if we want to find y prime, we could jump in, do a quotient rule, and it would be unpleasant but possible to do it directly. But here, logarithmic differentiation is going to make it a little bit easier for us. We'll see how. Okay, so here's y, and we want to find y prime, which is conveniently given here, so we can check. So y prime. Well, as I said, we'll do ln of both sides. And then we're going to apply a variety of log rules. Which ones? We're going to use them all. We're going to use all the log rules, well, all three that are kind of standard. First one, if you have log of a fraction, then that becomes subtraction. You like that rhyme there? Ah, tough crowd. Ln of a product will be, well, what do you think? If division becomes subtraction, then you probably guess that multiplication becomes addition. And the last one is the exponent can descend. So we have these three rules, column 1, 2, 3. The order doesn't matter, but there it is. Okay, we're going to use these rules to simplify this rectangle. And then we will do differentiation. So first we use our logs to simplify, then we do derivatives. Okay, let's go. So ln y is going to equal, well, the first one is, I use number 1 here, because I have a fraction, right? So I can go ln of e to the minus x cos squared x minus ln x squared plus x plus 1. Next, use this one to work this guy out. Plus ln cos squared x minus ln, nothing to do here. I will put that in green. If you have ln of, say, a plus b, this is in general not equal to ln of a plus ln of b. You're going to be tempted to do this, but resist temptation. It's just not true. We want it to be true, but it's not. Okay, next. Rule number 3, apply that here and here. The negative x comes down. Here, it's actually the power of 2. That's what cos squared means. It's actually a power of 2 coming down. And as I said with the last one, nothing to be done. Ln of e, what's that? You should remember that that is 1. Okay, oh, tedious copying this. Now what? Now I'll actually do calculus. Okay, all these steps here, quite a few of them were just log rules. Now I will actually do calculus. Take a derivative of both sides, and this is relatively quick. Plus 2 times minus sine x over cos x minus 2x plus 1. Okay, you'll notice that I'm using this formula. The derivative of ln y is y prime over y. Okay, I'm using that left, right, and center. I used it here, I used it here, I used it here. So, good one to memorize. So y prime is going to be y times -1 minus 2 sine over cos, that's tan. Just to make it a little bit easier to look at. A bit more pleasing to the eye. And then our original y can be plugged back in. What was the original y? The original y was this guy here. I'm going to cheat here and just copy, ooh la la, copy pasta here. Copy, 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 copy. Oh, forget it. I'll just remember what it is. Use my brain. Okay. E to the negative x cos squared x over that denominator, right? Okay, that's my y times the bracket minus 2x plus 1 over x squared plus x plus 1. Let's see how I did. Did I make a mistake? I feel like I did make a mistake. Well, I'm not getting the same thing as my answer, but I'm getting pretty close. What did I do wrong there? I don't see a mistake. So we'll just leave that for now. But the basic idea is to apply ln to both sides, simplify as much as possible using log rules, and then do a derivative of both sides. Okay, this may seem like a lot of work here, all this, but once you practice using these rules, they become second nature, and this all becomes much faster. But first, it's going to seem a bit tedious, but I encourage you to consider the alternative. The alternative is using the quotient rule here and having a big mess. Okay, practice. Here's an exercise. I want you to pause, copy, and try this now. And I will do a solution now. Ln of y is ln of this abomination and then once you practice, you can just do this very quickly. I'll just do it. Quickly here. Ln x squared plus 1 minus 5 ln 3x plus 2. One thing I use is that the x squared plus 1 square root, that's the same as x squared plus 1 to the power of a half. Okay, so now derivative of both sides, y prime over y. A lot of y prime over y happening here, eh? E x squared plus 1. Put my dot there, minus 5 dot 3 over 3x plus 2. Y prime is y times this. Blah, 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 3x plus 2. How am I doing so far? Okay, good. So my bracket here is matching that guy. You know what? I'm going to allow you to, it's annoying to have to copy this. So just say, you can just put a little arrow here and say given above. Okay, I'll allow you to do that as well. No need to spend all that time copying.